Now, let's move into the extra practice. Okay, everything we just practiced, we're going to need here. The first one, find an equation of a tangent line. Well, wonderful. We had this on our last quiz. We know a point will be 0, comma, f of 0. We know the slope will be the derivative at 0. Now, what is f of 0? Okay, evaluate this at 0. We have 5 over 1, which is 5. So I have 0, comma, 5. In fact, if you like slope-intercept form, in fact, I've given you the intercept. It is 5. But we can also use point slope. Perfectly fine. Well, now, to get the slope of the tangent line, okay, I need the derivative. This, I'm going to use chain rule. So you see my function itself, we can write as 5, 1 plus 2x plus x cubed to the minus 1. This is very similar to one we just did in the notes. Now take the derivative, chain rule. So we bring down the power minus 1, and I put in the entire inside function, 1 plus 2x plus x cubed. Okay, I'm not finished. Multiply by the derivative of the inside function, 2 plus 3x squared. Now, go back up here, f prime of 0. Okay, it's not too bad. It looks intricate, but look, we have minus 5 times 1 times 2. 1 to any power is 1. We get minus 10. All right, well, let me make this slightly smaller. I have everything I need here. So now we have the intercept, so we could do y is minus 10 x plus 5. Or you could use point slope form if you wanted to. Okay, that was a fun question. Now, you see these next 3 are very similar to these 2 that we just practiced from the notes. One reason I did this. Okay, f is differentiable. Now I have g, h, and p, which is built from f and some other things. Well, here we have to think. Product, quotient, chain, and could be multiple ones of these combined. Fundamentally, when I look at g, I see one function divided by another. And so I'm going to use quotient rule. Okay, so g prime of x, we have denominator times the derivative of the numerator minus the numerator times, well, when you differentiate the denominator, right here, technically, this is chain rule. Okay, let's write it. So bring down the power, okay, leave the inside alone to the 1, and then times the derivative of the inside function. Well, if the inside function has derivative 1, I mean, you don't really need to write it, but I did. Okay, and then all over the denominator squared. So it would bring it to the 4th power. Oh, here is g prime of x. Next one. Well, this is chain rule. My inside function is f of x plus the square root of x. My outside function is x to the minus 3. So there's the derivative of the outside. Bring down the power to the power minus 1, and then evaluate it at the inside. Okay, f of x plus the square root of x. Now, once we have this, we multiply by Derivative of the inside function. Don't forget your parentheses here. So we have the derivative of f is f prime. And then, well, as we were discussing here, 1/2 power. So bring down the power, x to the power minus 1. So here is h prime of x. Next one. This one I've had multiple questions on from students. It's a great one. So here, the f is my outside function, but I really have a sum of two terms. This one will be a chain rule, and similarly, this one will be a chain rule, but I have two different inside functions. So let's get started. P prime of x. We write down the 7. Okay, derivative of the outside, f prime. Evaluated at the inside, I put in the entire 5th root, which I can write as a 1/5 power, or you could write it as a 5th root. Either way. Now, multiply by the derivative of the inside function, 1/5 x to the minus 4/5. Okay, then we put a plus. So far, you see I have differentiated the first term, chain rule. Next, take the derivative of the second term, derivative of the outside, evaluate it at the inside, and then times, well, the inside function has derivative 2. Okay, so now I have differentiated the second one. Maybe I will erase this highlight. But this part is the derivative of the first term, and then this part is the derivative of the second term. Chain rule, both times. Okay, wonderful. Number 3, we have 5 derivatives. Do not simplify. We can expect power rule, product rule, quotient rule, chain rule. Okay, and maybe more of those combined in a single question. So the first one, we do see one function divided by another. If you wanted to jump in with a quotient rule and do not simplify, perfectly fine, full credit. However, I find it easier because my denominator is a single power to just break this into a sum of 3 fractions. So we have 9 over x to the 5th plus x cubed over x to the 5th plus we have 12 x to the 15 over 2 over x to the 5th. Each one of these I can write as coefficient times x to a power. Okay, so I am still writing y equals here. I have not differentiated anything, not yet. So I have 9x to the minus 5. I have plus x to the minus 2. And then I have plus, well, here I have 15 halves. Here I have 10 halves. So this would be a 12 x to the 5 halves. Now we can calculate y prime. This I will do in blue. Power rule, power rule, power rule. We have minus 45 x to the minus 6. Okay, minus 2 x to the minus 3. Okay, we have, this will be 12 over 2, which is 6 times 5, 30 x to the 3 over 2. Wonderful. Now, letter B. Here, fundamentally, I see one function divided by another, quotient rule. But when I go to take the derivative of the denominator, this will be chain rule. So g prime of y, we have denominator times, well, the derivative of the numerator is 1 minus the numerator. Okay. Derivative of the denominator is where I need chain rule. We have 1/2 power. So we take derivative of the outside, evaluate it at the inside, and then times derivative of the inside function, which is 3y squared. Okay, denominator, derivative of the numerator, minus numerator, which is here, derivative of the denominator, and then all over. But when I square the denominator, I just get this. Maybe I will put lines to separate. In a question like this, and I had this question today, a question like this is showing our work. If you just entered this into your calculator and say your calculator can take derivatives and it spits out something super simplified and that's all you write down, it would be really hard to award points because, well, it doesn't seem like a human calculated it by hand. So here we leave it unsimplified. I can see the work and the answer all in one. Very nice. Okay, H is a power rule question. So first, let's just rewrite everything as a power. H of x, we have 3, x to the minus 1. We have 6, x to the negative 7 over 2. Then we have 1 over 8, x. Wonderful. Now differentiate. Power rule in all three terms. We have minus 3, x to the minus 2. Here we're going to, when we bring down the power, 6 times negative 7 over 2 is the same as 3 times negative 7, which is minus 21, x to the minus 9 over 2, and then 1 over 8. Derivative of x is 1. Okay, letter D. Here, well, we are going to have a chain rule twice. So, first of all of this is my first inside function because fundamentally what I'm staring at is something to a power. And this is what sort of, by doing more examples, we can spot. Fundamentally, do I see a product? Fundamentally, do I see a quotient? Fundamentally, do I see an inside and outside function? And here, I see here, inside and an outside function. So, f prime of x, derivative of the outside is here. Evaluated at the inside, we have 4x plus 3 to the 7 plus 5x to the minus 1, okay? When we multiply by the derivative of the inside function, I need to differentiate all of this. And this first term in and of itself is chain rule. Okay, let me move this over. Times, don't forget your parenthesis there. Well, we have the 7 to the 6. Put in the entire inside function. So 4x plus 3 times derivative of the inside function. And then we have minus 5x to the minus 2. It's important we get our parentheses right in these questions. Otherwise, it's quite confusing to look at your work. Okay. Last one on this page is R of x. Fundamentally, I see a product. I see one function multiplied by another. See? One function multiplied by another. Fundamentally, this is product rule. It's just when I go to take the derivative of the second, which is underlined in purple, well, I will have a chain rule here. So, R prime of x, we have first times derivative of the second. This is our chain rule. That is derivative of the outside, evaluated at the inside, times derivative of the inside function, which is minus 9, x to the minus 4. Okay, so far we have first derivative of the second. Now, put a plus. We have second. And then when we go to differentiate the first, power rule. So we have 5 over 3 x to the 2 over 3. This is the derivative of r of x. Okay, well, take a deep breath. We calculated those 5 derivatives. Now we're on the third page. This is a wonderful question. Find all x values for which this function has a horizontal tangent line. First of all, what does this part mean? Horizontal. Horizontal lines, the slope is 0. So let's write that. This would say the slope is 0. So what am I trying to do in this question? Take the derivative, set it equal to 0, and find the x. Okay, well, f prime of x, we have 3x squared plus 6x minus 45. We can set this equal to 0. Generally, if we want to factor something and there's something common to every single term, it can be easiest to factor that out first. So here, every single term is a multiple of 3. Let's factor out a 3. I'm left with x squared plus 2x minus 15. Now, this is a little bit easier to work with. We have x minus and an x plus. I need two numbers to multiply to negative 15 and add to 2. So how about minus 3 plus 5? Check it. They multiply to negative 15. Very nice. And add to 2. Okay. So now I have two answers. Negative 5 and 3. Wonderful. Number 5. Oh, okay. F is differentiable. We're given information. F of 3 is 5, f prime of 3 is minus 3, and g of x is x squared, f of x. First, we want to differentiate g. So this is product rule. Okay, we have one function times another. Maybe I will underline one function times another function. Product rule. So g prime of x equals, we have first derivative of the second plus the second times derivative of the first. Now, evaluate at 3. Okay, g prime of 3 is 3 squared, f prime of 3 plus f of 3 times 2 times 3. Well, we're given f prime of 3. We are given f of 3. So we have 9 times minus 3 plus 5 times 6. Altogether, we have minus 27 plus 30. This is 3. Number 6. Last question. The number of bacteria in millions present in a culture is given by this function n of t. Here, t is time in hours from the beginning of our experiment. What is the number of bacteria present when t is 16 over 5? Well, this is not a derivative. The number present, we just evaluate at 16 over 5. Okay, so n of 16 over 5 is, well, we have 2 times 16 over 5 times the square root. Well, we have 5 times 16 over 5, which is 16, plus 9, and then add to this 12. Now, this looks intricate, but it's not too bad because this is the square root of 25, which is 5. So I have 5 over 5, which is 1. This first term altogether is 16 times 2, which is 32. So I have 32 plus 12, which is 44. And this is in million. We can write underneath or just answer 44. Letter B. What is the rate of change of the number of bacteria with respect to time when t equals 0? Look, rate of change. This is a derivative. Okay, so first let's calculate the derivative, then evaluate at 0. Now, derivative of 12 is 0. This is a constant, but you see what I'm looking at the first part, 2t times this square root. Fundamentally, this is a product. Oh, I'll underline. First, second. So I need to use a product rule. Then when I go to differentiate the square root 5t plus 9, chain rule. Wonderful. Okay, first times. Well, the derivative of the second, we differentiate 5t plus 9 to the 1/2. We take the derivative of the outside, evaluate it at the inside, and then times derivative of the inside function. Okay, what do I have so far? I have first, derivative of the second, and then we put a plus, second, which is the square root, 5t plus 9, times, well, my first function is 2t, its derivative is 2. Here is n prime of t. Now, we could, in fact, in the solutions I have posted in Canvas, I think I did, move this part into the denominator with a square root. Perfectly fine. But if we look at the question and what we actually need to do, I just need the derivative at t equals 0. And I can do that without actually simplifying here. So at 0, you notice I have 2 times 0 times something. So the first term is just 0. Then I have the square root of 9 times 2, which is 3 times 2, or 6. This would be million bacteria per hour. If you wanted to write the units. Okay, well, class, I know the chain rule can be a bit intricate, and I hope going over the extra practice questions together with 6 derivatives from the notes was helpful for you. Thank you so much.